In this video, we are going to derive the derivative of the arc cotangent of x. So pretty much we're going to find the derivative of the arc cotangent of x. Now, we may not know the derivative of the arc cotangent of x, but we do know the derivative of the cotangent of x. So what we're going to do is we're going to just say that y is equal to the arc cotangent of x. So, if this is true, then that means that x is equal to the cotangent of y. And so now that we have this idea, pretty much all we have to do is we have to take the derivative of both sides of this equation with respect to x, and then just solve for dy over dx. And that will give us the derivative of the arc cotangent of x. So that's what we're going to do, okay? So we'll first start out by taking the derivative of both sides with respect to x. Right, and so now that we have this, we just got to evaluate both sides of the equation. Right, the derivative of x is just going to be 1. And we know that the derivative of the cotangent of y is just going to be the negative cosecant squared of y. However, that's not all we have to do, because we're taking the derivative of this with respect to x, which means we're using the chain rule. So we have to actually multiply by the derivative of y with respect to x. So we're multiplying by the derivative of y with respect to x. So now that we have this, all we have to do is just solve for dy over dx. Right? So that's what we're going to do. So solving for dy over dx, what we're going to get, this is good. Solving for dy over dx, what we're going to get is we're going to get negative 1 over the cosecant squared of y, right? That's pretty much what we're going to get. So now that we have this, now what we have to do is we have to substitute y for something in terms of x. And we know that y is equal to the arc cotangent of x. But if we substitute y for the arc cotangent of x into here, we'll be doing the cosecant of the arc cotangent of x and then squaring that, and that's just going to make things a little more complicated. And we can actually do this a way easier way. So think of it this way. If we're taking the cosecant of y, that's pretty much just treating y as an angle, because normally we take the cosecant and we take the cosecant of an angle. So we could just treat y as an angle of a right triangle. And so that's what we're going to do. We're going to do that. All right, so we're just going to draw a right triangle right here. And so this is our right triangle. And we're going to say that angle y is right here. Right, so we're going to say this is angle y. So now that we know that this is angle y, in order to find the cosecant of y, we just need to know what these side lengths are. So how do we figure out these side lengths? Well, it turns out we already have the answer to that question. Because right here, if you notice, what we have here is the cotangent of y equals x over 1. And this idea can be implemented to the sides of our triangle. And so pretty much, if the cotangent of y equals x over 1, cotangent is just adjacent over opposite. So cotangent of y is x over 1. So x over 1. And so knowing this, you can find the third length just using the Pythagorean theorem. And it's just going to be 1 plus square root of 1 plus x squared. Right? And so now we know all three lengths of the triangle. So now that we know that, we have all three lengths, so we can figure out the cosecant of y. Right? Right? And so pretty much the derivative of y with respect to x equals the cosecant of y. When we do that, right, the cosecant of y, cosecant is just hypotenuse over opposite. So it's going to be hypotenuse over opposite. We just get the square root of 1 plus x squared we take that and we square it, right? And when we square a square root, that's just going to result in the, pretty much without the square root. When we square square root, the square root goes away, and we're left with 1 plus x squared, right? So we get negative 1 over 1 plus x squared. And so this is the derivative of the arc cotangent of x. So this would be it. We've now figured out the derivative of the arc cotangent of x. That's it.